So, all of this is going to sound like complete gibberish, but, a lot of things are gibberish these days. So, the Basic Handbook by Lien. David A. Lien. Copyright 1981. So, gibberish away. Page 44. Function, CDBL. CDBL is used to change numbers or numeric variables from regular single precision to double precision. The variables used in the CDBL function return to their original single precision status if they are used again without the CDBL. Double precision variables are capable of storing numbers containing 17 digits. Only 16 digits are printed. Single precision variables are accurate to 6 digits. Great care must be used to ensure that the numbers which are used to create a double precision answer are also double precision. If not, the answer will be a big long lie. And this is the gibberish part. So, test program. Line 10. REM CDBL test program. Line 20. X equals 2. Line 30. Y equals 3. Line 40. Print CDBL changes x slash y from semicolon x slash y semicolon quotations 2 end quotations semicolon CDBL parentheses x end parentheses slash CDBL parentheses y end parentheses. Line 50. Print quotation and back to the value of quotation semicolon x slash y semicolon when removed, end quotation. Line 99 end. Sample run. CDBL changes x slash y from 0.66667 to 0.6666666666667. Variations in usage, none known. Also see DEFDBL, DEFSNG, DEFINT, CSNG, hashtag, exclamation point, percentage, and CINT. Page 45. CH is a function in the Acorn Atom computer that identifies the ASCII number of the first character of a given string. For example, print CH quotation Acorn end quotation will cause 65, the ASCII value of A, to be displayed on the screen. Only the first character of a string is identified by CH. See ASC for more information. More gibberish. Line 10, REM CH test program. Line 20. Print the ASCII code for letter A is line 30. Print CHA. Line 40. If CHA equals 65, then 70. Line 50. Print CH failed the test. Line 60. Go to 99. Line 70. Print CH passed the test. 99. End. Sample run. The ASCII code for A is 65. CH passed the test. Variations in usage, none known. Also see ASCII code CHR $, and Appendix A for the ASCII code. Page 46. Statement. Chain. Chain is used to load a new program into the computer's memory from an external device, such as disk or tape, and execute that program without additional run commands. A program may chain to any other program, including back to the starting one, which may serve as a menu. The main advantage of chaining is that it permits consecutive execution of related programs automatically without needing to keep more than one of them actually in the computer at a given time. This is especially useful where there is a common file of data stored externally which can be accessed and manipulated by programs in the chain. Chain finds its best application in systems large enough to have disk storage with fast access times. If the values of variables are to be carried from one program to another, a separate file must be created for them. Before such a program is allowed to chain to another, it must save the values of its variables in this file so the new program can read them back and prior to its execution. Some basics are able to pass the values of the variables used by the first program directly to the second. Microsoft Basic 5.0, for instance, accepts the statement chain quotation prog2 end quotation, comma 150, comma all, which chains to a program on disk called prog2. Prog2 begins execution at line 150 after receiving values of all the variables that had been previously been defined by the calling program. The new program's name must be included after the chain statement. Some computers specify the new program's starting line number by a number following the program's name. If the starting line is omitted, the computer automatically starts at the new program's beginning. For example, line 10, chain test, comma, line 30 tells the computer to erase the program presently in memory and load a program called test from external device, then start execution at its line 30. The external storage device can be specified in some computers, e.g. the DEC-10 BASIC, by placing the device name after chain followed by a colon. For example, line 10, chain, PTR, colon, test, comma, 70. This tells the computer to load a program named test from the paper tape reader and start execution at its line 70. Page 47. Test programs. Save this program on disk or tape under the name test. Line 10. rem, asterisk, test, asterisk, program. Line 20. Print the quotation, the single quotation, test, and single quotation. Program is now running, end quotation. Line 30. For x equals 1 to 9. Line 40. Print x, semicolon. Line 50. Next x. Line 60. Print quotation. This program should now chain back to the main program, end quotation. Line 70. Chain main, comma, 40. Line 99. End. Now enter the main program into the computer and save it on disk or tape under the name main. Line 10. rem, asterisk, main, and asterisk, program. Line 20. Print quotation. This program should load and run the single quotation test and single quotation program quotation. Line 30. Chain test. Line 40. Print quotation. Chain past the test if the single quotation test and single quotation program end quotation. Line 50. Print quotation. Printed a series of numbers end quotation. 99. End. Prepare your disk or tapes to be read on command, then run. Sample run. This program should load and run the single quotation test program. The single quotation test and single quotation program is now running. 1, 2, 3, 4, 5, 6, 7, 8, 9. This program should now chain back to the main program. Chain past the test if the test program printed a series of numbers. If your computer doesn't have it, chaining can be accomplished successfully, if more slowly, on microcomputers using floppy disks or even cassettes. Most small system basics start each new program chained at its first line number, not having the option to start elsewhere. The following 3 programs demonstrate how chaining can be accomplished on a TRS-80 disk system. The word run is used instead of chain. Note the new program's name is enclosed in quotes. Line 10. rem, asterisk, main, and asterisk, program. Line 20. Print. Line 30. Print. Quotation. This is the main control program. End quotation. Line 40. Quotation. Shall we, single quotation, chain, and single quotation to program number 1 or number 2. Parentheses, type 1 or 2, and parentheses, end quotation, semicolon, I. Some more. Page 48. Line 50. Print, quotation. Stand by for loading, dash, 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 end quotation. Line 60. On I, go to line 70, comma, line 80. Line 70. Run, quotation, test 1, end quotation. Line 80. Run, quotation, test 2, end quotation. 99. End. Line 10. rem, asterisk, test 1, end asterisk, program, line 20, print, quotation, test program, number 1 is now running, enter quotation, line 30, for x equals 1 to 9, line 40, print quotation, 1, end quotation, comma, line 50, next x, line 60, print, line 70, print, quotation, we will now chain back to the main program, dash, 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 end quotation, line 80, run, quotation, main, end quotation, line 99, end. Line 10, rem, asterisk, test 2, end asterisk, program. Line 20, print, quotation, test program under number 2 is now running, end quotation. Line 30, for x equals 1 to 9. Line 40, print, quotation, 2, end quotation, comma. Line 50, next x. Line 60, print. Line 70, print, quotation, we will now chain back to the main program, dash, 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 end quotation. Line 80, run, quotation, main, end quotation. Line 99, end. Type in each program and save it on disk under the name given in each line 10. Then run the main program. Watch the screen and disk drives, chain the programs together and execute them. Variations in usage, none are known. Also see load, save, common, and run. It's 11 minutes. Okay. A little more. Statement. Statement, change. Capital letters. Change is a statement used by the DEC-10 computer to convert strings of characters to their ASCII numbers and numbers back to character strings. Change x $ to x converts each character in string x $ to its ASCII number and stores them all in an array named x. The length of the string len parentheses x $ and parentheses is stored in an array element of x parentheses 0 and parentheses. Change x to x $ converts values stored in array x into a character string x $. The number of values to be converted is found in x 0. Each value of x must be between 0 and 255. Test program number 1. Line 10, REM. Single quotation, change x $ to x and single quotation, test. Line 20, dim x parentheses g and parentheses 30 x $ equals quotation system end quotation. Line 40, change x $ to x. Line 50, print quotation, change has converted single quotation system and single quotation to end quotation. Line 60, for n equals 1 to x parentheses 0 and parentheses. Line 70, print x parentheses n and parentheses semicolon. Line 80, next n. Line 99, n. The sample line, change has converted system to 83, 89, 83, 84, 69, 77. Test program number 2. Line 10, rem. Single quotation, change x to x $ and single quotation, test. Line 20, dim x of g. Line 30, read x of 0. 40, for I equals 1 to x of 0. 50, read x of I. Line 60, next I. Line 70, change x to x $. Line 80, print quotation, change end quotation, semicolon, x $, semicolon, quotation, the test, end quotation. Line 90, data 6, 80, 65, 83, 83, 69, 68, line 99, and sample run, change, pass the test. If your computer doesn't have it, change can be stimulated by using len, ask, mid $ and chr $, and test program number 1, replace line 40 with line 40, x parentheses 0 and parentheses equals len parentheses x $ and parentheses. Line 41, for I equals 1 to x parentheses 0 and parentheses. Line 42, x parentheses I and parentheses equals ASC parentheses MID $ parentheses x $, comma I, comma 1, end parentheses, 43, next to I. In test program number 2, replace line 70 with line 70, x $ equals quotation, end quotation, 71. Now line 71, for I equals 1, 2, x parentheses, 0, end parentheses, 72, x $ equals x $ plus CHR $, x, parentheses, I, end parentheses, line 73, next I. Also see len, comma, ASC, comma, MID $, comma, CHR $, comma, DIM, and refer to the C table in Appendix A. Oh. That's a lot of stuff. Okay. I think I'm tired enough that even if I read it silently, I would still be too tired to read, so I'm just going to cut it off. Yeah. So we stopped at page 51.